Good afternoon. The title of my presentation today is a little bit misleading. I seem to be implying that E. coli are fiends. But over the course of the next 3 minutes, I hope to show you why, in the fight against waterborne illness, E. coli may be better thought of as friends than as fiends. So I'm going to lead you through the 4 main points that underline my thesis. I'm going to lead you through them out of order, and then I'm going to bring them all back together. So here we go. Point 1. Access to clean drinking water is severely lacking around the world. The World Health Organization estimates that 1.8 billion people, this is 25% of the world's population, get drinking water from fecally contaminated sources, and that this leads to at least 500,000 deaths every year. Now, at the Portland State Sweet Lab, we focus much of our time on the development of sensors to monitor water-based technologies. This includes hand pumps, water filters, and water testing kits. And this has led to an ecosystem of public health technology sensors that are able to interact with cell phone towers, and they're able to transmit data to the internet, even from very remote locations. Point 2. Some molecules fluoresce, and this means that if you hit them with particular wavelengths of light, their electrons are excited to a higher energy state, then immediately drop back down. Now, that energy has to go somewhere, and it goes into the form of a different wavelength of light, and this can be used to identify these molecules. In fact, spectrometers that use this effect can find single molecules in a solution. A good example of a fluorescent molecule is the amino acid tryptophan. Point 3. E. coli are what's known as an indicator organism, which means that although they themselves usually aren't harmful to humans, their presence uniquely indicates a contamination event. Now, in cities like Portland, we routinely test our water for E. coli using a process that involves providing them with a sort of ideal bacteria food, incubating for 16 to 24 hours, and then finding a way to count the colonies. Now, this requires trained lab technicians, sterile environments, a constant supply of consumables, and most importantly, a lot of time. Now, this isn't too much of a burden to bear for a city like Portland, but in developing countries all over the world, these technologies are much more difficult to deploy. So this brings me to point 4. High levels of tryptophan can be associated with high levels of bacterial activity. My research builds on other recent work showing a strong correlation between tryptophan fluorescence and the presence of thermotolerant coliforms, a group of indicator organisms that include, you guessed it, E. coli. So to bring this all together, here's a surprising fact. In the world of public health, there's really no such thing as a bacteria sensor. Not yet. But in the near future, water resources in the most at-risk parts of the world could be monitored around the clock. So my thesis focuses on the development and the testing of an online, on-site, fluorescence-based bacteria sensor to monitor water quality, detect contamination events, and aid in research with the help of our fluorescent friends, E. coli. Thank you.